still not visible to me. Farhan, Safiya. Hello, Safiya. Assalamu alaikum. How are you?
Walaikum salam, sir. How are you?
I'm good. I'm good. Thanks so much for asking. Acha, how many of you have got the marks from the school and you haven't shared yet? I didn't get any of the marks of my students. If you get the
Yeah,
marks, please share with me on the official number. Like only
okay, sir.
please share the marks or report card or mark like answer sheet, whatever you have, so that we can discuss, right? Because I just wanted to tell you that where you have made mistake, right? So
Yes, sir.
that would be much more beneficial for you, right? So please share
Yes,
your
sir.
marks, check the sheets, whatever you have get so far from the school,
Yes, sir.
right?
Sir,
So
it's
Irshad, yes, Safiya. Oh, sorry, Tejas.
sir. Yes, sir. Not till now, sir.
Okay, no issues. Did they share the marks?
Yes, sir. No, sir.
Did they share the marks?
No, sir.
चलो ठीक है कोई बात नहीं तो इरशाद सफिया Farhan, please switch on your video. I'm asking continuously. It's your responsibility to switch on your video without any reminder, right? So this is a class. So the request, humble request to all of you, please switch on your video once you enter the class. Okay? Your privacy is completely maintained. No need to worry. I can only see your videos. You cannot see the videos of each other. And one more thing, if this class is getting recorded, so only my video is getting recorded. Your video is not getting recorded. So do not get worried about it. Okay, everyone? So
Yes, sir.
your privacy is maintained, everything is maintained. Okay? So only my video is recording, even you have shared, even if you have switched on the video, only my video will be recorded as well. I can only see your videos and you can only see the video of mine. Okay? I'm the only one who can see the videos of Asif, Irshad, Tejas, Safiya, Sara, Farhan. But you cannot see the video of each other except mine. You can also see, like you can all like only see my video. Okay? Sure, that's great. Farhan, are you there? Farhan? Maybe he is there, but not responding, or maybe some mic issue. If you are there, please let me know in the chat. Yeah, just stop
Yes, sir.
exploring the themes.
Sir,
What are the formulas written in the background? Farhan, why
sir,
are you
let me
not responding, बच्चे? अच्छा 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 ठीक 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 ओके नो इश्यूज अच्छा अच्छा ओके अच्छा ठीक 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 कोई बात नहीं so सिर्फ you can switch off your video if you are having network issue no issue
Oh, okay, sir.
no issue Acha, one more thing also. If you can inform me if you're having network issues. Like so my network is lagging or something like that. So that is acceptable. I can directly say you that you can switch off your video. But if you're having no internet issue, no lagging issue, nothing, and still you are not switching on your video, so that is not. Okay? Chalo, that's great. Now let's start the class without any delay. Okay? जल्दी से करते हैं class start. So in the previous class, we have basically discussed about the effects of gravity, right? And one more thing
Yes,
about that, the gravity, like this explanation only, the theoretical portion is there, no calculation is there that how do we get to 9.8 or 10 meter per second square. This is in 11th class. You will study the gravitation chapter in detail in the 11th standard. In that chapter, you will get to know that why is it 9.8, why is it 10, what right, and how to calculate the different value of these at different heights or depth. ठीक है चलो that's great ठीक है so basically the value of g is not constant everywhere on the earth itself. It continuously changes, right? So let me tell you, right? So this is the eighth part because everyone, these all these parts related to acceleration due to gravity are very very important, everyone. So it's a request to all of you, please and please give extra strain to this topic specifically because most of the students find difficulty in this topic itself. That okay. Next topic, next line is, so in the previous class I just got in the flow and I just like I forgot to end the class and you were thinking that that was a 1.5 hour class. Okay, so take it, that's great. So that is 8 points. So the value of I said for now, am I audible completely?
Not completely.
Acha, maybe you have like serious network issue. Or you can change your position. Maybe there is some issue with the like. Are you on Wi-Fi or mobile data?
So Wi-Fi.
Wi-Fi. Okay. Maybe so there might be an outage. So basically, that is the most embarrassing thing that when you are basically on the Wi-Fi and still Wi-Fi is behaving like a mobile data,
Yes, sir.
right? चलो कोई बात नहीं, ठीक है ठीक है value of g so it's not constant, everywhere at all places basically. Safia, did you share the marks on the official number?
Sir, by the way, I think on Sunday I messaged the team about the physics homework.
Uh, okay. What was the reason? Well, I didn't get it. Could you please explain it a little
Sir,
bit?
like you gave a homework for universal law of gravitation,
Ah,
right?
ah,
So assignment in that when I opened the assignment, it was some 10th grade trigonometry questions.
Acha. Okay, maybe they might be. हाँ, Tejas also pointed out that thing in the
Yes,
last
sir.
class. Yeah, yeah. Chalo, okay, okay. That's it. That's it. I'll also ask them to basically check it and replace the assignment, actual
Sir,
assignment. Okay?
you have replaced the assignment, sir.
They did replace the assignment?
Yes,
So
sir.
they didn't.
For me,
Okay.
they did, sir.
Okay, okay. No issues. I will check it again so that it is visible to all of you. Okay? No need to worry. So,
Okay.
first off, thank you so much for informing me that and Tejas. Okay?
Yes,
So,
sir.
surface of Earth. So, value of G is not constant at all parts of the Earth. It continuously changes. That is due to the distance between the center. Because value of G depends on the radius. If the radius is getting increasing or getting decreased, so it changes, right? So let me tell you what are the effects. So next line is the ninth line or the ninth point.
Sir,
That is the radius of the Earth at poles. Poles mean that. So let me tell you. With the help of the diagram because it would be much more clearer to you.
the radius of Earth is 3.84 into 10 to the power 5 kilometers, right?
No, 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 no. That is the radius of moon, Tejas. That is not the
Okay.
radius of Earth. That is
Okay,
radius
sir.
of Earth is uh, 6, uh,
6 points.
6.4 into 10 to the power 3 kilometers,
Okay, sir.
right? Okay. So everyone see this thing. Poles mean this point, center to this. Pole means this north pole, south pole. That's what we say. North pole and
Yes,
south pole.
sir.
Yes or no? Right. So as you can see, Earth is not completely square. It's a little bit flattened, from the upper portion at the north pole. So as you can see, this if I say this thing, it is a little bit elliptical. Instead of that, just a second. So suppose this is the center of Earth, and you let me use the blue color. Is it visible? Not visible.
No, sir, it's not clear that much.
Blue color is visible.
Yes,
Let
sir, it's
me
visible.
use any other color. If maybe later. So as you can see, everyone. Okay, so this is the distance from the center to the pole, and this is the distance, basically your equator, right? So as you can see, everyone, that this is greater distance than this. This is at the pole. This is at the equator. So am I clear to all of you?
Yes, sir.
Yes, sir.
Right. So that's why the radius of Earth at equator is greater than the radius of pole. Okay. So that's why
Yes,
the
sir.
value of G at poles will be higher. It means that, let me write it over here. Just a second. The radius of Earth at the pole is minimum. Okay, is minimum. So the value of G at poles will be greater. Here, everyone,
Yes, sir.
at pole, the value of G is maximum at pole. Clear to all of you? Please do let me know. And
Yes,
the
sir.
last part would be the radius of Earth at the equator Okay, sure, sure. At the equator is maximum. Okay. Just let me write it. First one is max is maximum. Okay. So the value of G at equators will be minimum. Am I clear?
Yes, sir.
So at equator would be minimum. Is minimum at the equator. Okay. Acha, tell me, Bacho, that is there any difference in my writing from the previous chapters, or is it same to you?
Sir,
Is
it's
it-
but
It's better, no? So I'm
yes,
trying to work more on my writing. Chalo, that's it. Okay. Am I clear to all of you? Please do let me know. So these are the factors, these are the characteristics for the value of G. Okay. I hope it's clear to all of you. Please do let me know.
yes, sir.
Any doubt so far to you, Bacho? Let me
No,
check
sir.
one thing. The NCRT. Just a moment. Give me a moment, Bacho. That I just wanted to check something. Okay, so now let's understand like the formula to calculate the value of g given as. Okay, so there is a very basic formula so that you can use to calculate the value of g. So there would be a very basic question, not a very tough question on that, right? So let's calculate it just a second, if you want. Okay, so that would be. So now the next thing that we are, so the value of g can be calculated as g is equals to gm by
Please.
r square. So what is basically g and what is r? Let me tell you one more time. So g is the small g is the acceleration due to gravity. M is the mass of the earth. R is the radius of the earth. So the value of g only depends on the mass of the earth and the radius of the earth, right? It means that if you increase the distance of the body from the earth, so value of g will decrease. If you decrease the value, so it will depend. Clear? So now let's
Yes,
do a
sir.
question based on that so that you can imply this question in the as a formula, because this question is basically in your NCERT book as well. Okay, so that let's do it together. That's how we get the value of g as 9.8 meter per second. So basically the value of g is 9.8 meter per second is at the equator and 10 meter per second is at the pole. Okay, so that is the thing. Clear over suppose is there anyone who's having doubt till now? Please do let me
Oh, sir.
No,
know.
sir.
Sure?
Sure, sir.
Any doubt? Sure.
No doubt.
Sure, sir.
No doubt, sir.
So okay, just a second. Yeah, I just forgot. Okay. Okay, let's calculate it first. Instead of basically, let's calculate the value of the g first of all. Okay, because there is a derivation in it. Okay, so because okay. So here we are going to calculate the value of g. Okay, how to derive the formula? Calculation of acceleration due to is capital. Okay. So suppose that everyone, if I drop a body from a height, right? If I drop a stone or if I drop a ball, so that body will have smaller mass because as compared to us, so we are taking the smaller mass as m, small m, right? So if I drop a body, this, so so this is the explanation for it. Okay. Lect mass. So let the mass of the stone as small m. Okay. Be m. Okay. Let the mass of stone would be m. Clear everyone?
Yes, sir.
Yes.
Okay. So now what you will do is that basically if the mass of the earth, if the sorry mass of that stone is falling from a height, right?
Yes, sir.
And this and mass of earth be capital. Okay, right? So according to the law of gravity, universal law of gravitation, so force exerted, okay,
Written M and G or capital M?
Yes, Imran. Yes, Tejas, you said something.
So it is M or MG.
Which one?
Sir, Earth. No,
Mass
sir.
of Earth be M,
Okay, okay.
capital M. Okay.
Yes, sir.
Then the force exerted by the Earth would be force exerted by the Earth on that stone is, so you know this thing that every body attracts, so there will be force according to the universal law of gravitation, that is F is equals to G M M by R square, that is R is the radius of the Earth. Am I clear to all of you? This is our equation number one.
Yes, sir.
Is there
Yes.
anyone who is having doubt? Okay, tell me everyone that if there is a body, if there is a force exerting on that body, so there would be some acceleration. If Earth
Yes, sir.
is exerting some force on a body, so there would be some acceleration produced in that body as well,
Yes, sir.
right? So in the second part,
The
the
equation.
force the force exerted by the Earth produces acceleration okay, that acceleration in the stone due to stone moves downward, right everyone?
Yes, sir.
Yes, sir.
Downward. Okay. So we know this thing, but that F is equals to that would be F is equals to M into G, because acceleration that is produced by the force of Earth, that is G. That's what we have just studied. That acceleration, pure acceleration, the under the influence of gravitational force is G. That is acceleration due to gravity. Yes or no, everyone?
Yes, sir.
This is
Yes,
our
sir.
equation number two, right? So as you can see this thing, everyone, that I can equate equation one and two because force is also
Yes,
there,
sir.
because same force is this force is basically attracting, exerted by the Earth on the body, and this force is also is same in magnitude, because this is due this uh, the acceleration produced is because of this force. Okay, so from equation 1 and 2, so I can write it as mg is equals to g mm by r square. Okay, m will get cancelled by this. So what you have got, Bacho, that g is equals to g m by r square. Please do let me know, everyone, if it's clear to you or not. Any doubt so far to any?
No, sir.
Sure. Are you clear to? Is this clear to all of you?
Yes, sir.
Okay.
Yes, sir.
That's how the value of g is calculated. You know this thing that g is a universal gravitational constant. Mass is the m is the mass of Earth, and r is the radius of the Earth. Clear, everyone?
Yes, sir.
Yes, sir.
Any doubt so far to anyone?
No, sir.
Sure. Now
Sure,
Sure,
let's
sir.
sir.
now we can calculate. Now we can do a question based on that. Okay. So now
Sir,
let's
can you
do a.
little? I want to write.
Sure. Here it is. So this is a small calculation over here. So this might be a question in your exams as well.
Okay, sir. Done.
Then China. So that is okay. Next is the calculate the value of acceleration due to gravity on the surface of moon. So we have to calculate the acceleration due to gravity on the surface of moon, right? And okay, just a second. Let's do a question first for the Earth. Okay, let's do this first. Just a second. Yeah. So calculate the value of g value of acceleration due to gravity on the surface of moon. Okay, mass of the moon is 7.4, radius of the moon is 740 kilometer. G is the given here. Okay, so let's write all the things. That is Newton, Newton square, kg square. Okay, mass of the moon is 7.4 into 10 to the power 22 kg. R radius of the moon. Okay, right now kilometer is not the SI unit, so I have to convert this into SI unit. So I have to multiply it with the 1000 into 1000 meters. So that would be 174 into 10 to the power 4. Now substitute the values over here and let me know the answer before try it.
Sad or not?
Okay, sir.
Any answer, anyone?
Not sure.
अच्छा
I'm not also getting.
अच्छा
Just 2 minutes.
अच्छा let me tell you the answer. Okay, let's calculate. So the value of to calculate the value of g can be calculated with the help of the given formula, that is gm by r square, that is equals to 6.7. In this chapter, calculations are very big and a little bit complex as compared to the previous chapters we have done so far. Okay, so that is 6.7 into 10 to the power minus 11 into mass of the moon is 7.4 into 10 to the power 22. Okay, and radius of the earth, moon would be, that is r square is 774 into 10 to the power 4 meters. Okay, square. So that would be, so देखो, if you multiply this thing, okay, okay, let's calculate. ठीक है, तो देखो, if bases are same, so the power will get added up. This is negative 11, this is positive 22, so it would be positive 11. So 6.7 into 7.4 into 11, 10 to the power 11. Clear to all of you?
Yes, sir.
ठीक है, 10 to the power 11 divided by 174 into 174 into 10 to the power 8. Right, everyone? Because
Yes,
4
sir.
to the 8. So if you take 10 to the power 8 in the numerator, so it will get negative. It will become negative 7.4 into 10 to the power 11 into 10 to the power minus 8. Clear to all of you? Please do let me know. Divided by
Yes, sir.
174 into 74. Is there anyone who is having doubt? Please do let me know.
No doubt, sir.
ठीक है? So that would be 600. That would G would be equals to 6.7 into 7.4 into 10 to the power 3 divided by 174 into 174. Clear?
Yes, sir.
ठीक है? Any doubt so far to anyone? ठीक है? So see this thing. If you multiply this thing, na, so that would be 67 into 74 into 10 divided by 170. ठीक है? ठीक है? So that the value of this would be equals to, just a second. So if you multiply this thing, so let me take it. So that would be 1.63 meter per second square. 1.6 to 1.63. That would be same.
Then my answer was correct, right?
Ah, yes, yes. Any doubt so far to anyone? Please do let me know, बच्चों.
No doubt, sir.
ठीक है? अच्छा, this is a very important thing, that the value of G at the moon is 1/6 time of the value of Earth. ठीक है. Value of G, just a second, Mr. My pen got stopped. The value of G of the on the moon is about 1/6. So this is very important result before. 1/6 of the value of Earth. ठीक है. क्लियर हुआ सबको ये?
Yes, sir.
Yes, sir.
Of G ठीक है. Any doubt so far to anyone? So
No,
you can
sir.
write as Gm. It means that the gravity acceleration due to gravity on moon is 1/6 of the gravitation acceleration due to gravity on the Earth. Clear, everyone?
What is GE?
Ge means
1/6, right?
acceleration due to gravity of Earth.
Okay, sir.
1/6 means देखो 1/6 if you multiply 1/6 into Ge, so 1 into Ge would be Ge. So you can also write this thing as, no need to worry if you are getting confused, you can also write this thing as 1/6 of Ge. So this would be same
Okay,
cases.
sir. Okay, sir.
ठीक है? Yeah. So that's why I've written. Please do let me know everyone if it's clear to you or not. Any doubt so far to anyone?
No doubt, sir.
ठीक है?
Sir,
ठीक है?
so in
Clear
the
everyone?
exam we
हाँ.
can write that also, right?
Which one?
Sir, which you have written 1 by
हाँ,
6
that is
into G.
also. Yeah, yeah. That is also.
Okay, sir.
That is not wrong at all. ठीक है? Any doubt so far?
No, sir.
चलो, that's it. ठीक है? So this is all about the acceleration due to gravity. Just a second, let me take the next topic. ठीक है? Okay, so now in the next topic that we are going to discuss is the equations of motion for the free falling body. Right? So let me write it over here. Right. So in the last class, in the motion chapter, we have studied about the equation of motion for freely falling body. So basically, this is the topic which is related to the motion chapter that we have done so in the previous classes, right? Falling for free body. Okay, so now let's understand. So in the motion chapter, the general equations were, I hope you remember this thing,
Yes, sir.
that, right? V is equals to U plus AP, right? Second equation was S is equals to
UT plus half AT square.
A plus half AT square. Okay. Third is
V square is
V square minus U square is equals to 2A. Okay. Now let's talk about the equations for the free falling body, right? So now instead of in place of acceleration due to gravity will be introduced. Clear, all of you? So in place of acceleration,
Yes,
that
sir.
was a general acceleration. Now we are talking about the gravitational force. So the acceleration produced by the gravitational force would be acceleration due to gravity. Second would be, so right now instead of distance or displacement, height will be introduced. Right, height will be introduced means that we are basically dropping a body. The body is getting dropped from a height. So we are talking about the gravitation. So it's all about the vertical distance, right? So that would be height ut plus half
V square.
gt square. Okay. In the third equation, that would be v square minus u square is equals to 2gs. Here, all of you.
Yes, sir.
Yes, sir.
Any doubt so far?
No, sir.
No, sir.
Chalo, any doubt so far to anyone?
No,
No,
sir.
sir.
No,
Sure.
sir.
Okay. So these are the three equations of motions that we are going to that we have modified for the free falling body. Okay. So now let's do some a little bit you can say the properties based on that, right? So this first point about this would be, so we will be taking if the body is basically coming downwards, it means that towards the earth, it means that velocity is increasing because the initial velocity was zero and before hitting the ground, there would be some velocity. So it means that the body is accelerating due to gravity. So we will be taking G as positive in the downwards direction, right? So let me write it here. When a body vertically downward, its velocity is increasing. So the acceleration due to gravity acceleration due to gravity, G, is taken to be positive. Okay, is taken as. So these are the sign conventions that you will be using in this topic. Clear?
Yes, sir.
Okay. So the value of G would be positive 9.8 or 10 meter per second square. Okay. Okay. B part. That is when a body is thrown vertically upwards, So in that case, everyone, the velocity of the body will continuously decrease, because if you throw a ball, so at certain point the velocity would become zero. So in that case, acceleration is nothing but retardation. Okay, it's decreasing. When a body is thrown upwards or vertically upwards, basically, its velocity is decreasing. Okay, decreasing. So the acceleration is also decreasing. Okay, so acceleration due to g, so due to gravity, that is g. Okay, is taken as negative. Clear, everyone?
Yes, sir.
That would be any doubt so far to anyone?
No, no,
Okay.
sir.
Acha, basically when the body is dropped from a height, freely from a height, so its initial velocity would be zero. Okay. From a height, its initial velocity is zero. Initial velocity would be zero. Is that clear to all of you? D part.
Yes, sir.
Next is when a body is vertically thrown upward, so the final velocity would be zero. Okay. Okay. Vertically upwards, its final velocity is zero. Okay. Next is, so everyone, next point is, that is very important point, is that if you throw a ball in the vertical direction, the time taken by the ball to reach that highest point will be equal to the time taken to reach that same point. It means that if you throw a ball like this, so time taken was suppose t. So to reach the same point, time taken would be same. It means that t1 will be equal to t2. Okay. So the time taken by the ball to reach the highest point will be equal to the time taken by the ball to fall from the highest point to the same point. Okay. So time taken by a body to rise highest point is equal to the time ठीक है it takes